Hello, today's story is going to be about functional programming. I'm not going to read this, and that's basically it. That's the main reason why functional programming is unpopular and hated from, well, around the world. So let's start by, well, short introduction. I'm BRANISLAV. I'm Drupal 7 and Drupal 8 developer. I'm doing a little bit of front end, I'm doing a little bit of Node.js, and I work for Platform SH, which is a company providing hosting services on steroids. Who knows about Platform SH? I don't want to bother you too much with it. It's awesome. So this presentation is going to be delivered in really terrible accent due to the fact that I was born in this country, to mother from this country, father from, well, combined from these countries, and the entire country fell apart into these countries. And then I decided to, I continued living in this country, and then decided to emigrate to this country, working for English-speaking yet French company with people all around the world. So yes, I love diversity, my company is diverse, and my terrible accent is terrible, so yay for terrible accents. This is my family, so I'm kind of a father and a husband and a cat herder. And who are you? So how many PHP developers like doing PHP stuff here? JavaScript developers. Okay, not that many. And how many of you tried functional programming? Haskells and things, no? Okay, so in order to understand functional programming, we have to understand, the history of computing. So let's start from the beginning, there were people who were designing a general purpose computer, and we didn't really know how will a general purpose computer look like. So that was kind of the goal. And we had this guy who knows about Alan Matheson Turing. Okay, so he was, well, we consider him today as father of computing, modern computing. He invented something called Turing machine. Who knows what Turing machine is? Okay, so it's basically a mathematical model. You have a rule book, and then you feed data into rule book, and then rule book starts, going through the data, changing the data, and finally it ends up with a solution based on given rules. So that was his model, and that was his idea of automated computing things and, excluding humans from making decisions. His PhD supervisor was Alonzo Church. Who knows about this guy? Much less people. Well, he also had idea about computing, and he also had idea about this general purpose computer, which was much more mathematical than Turing's state machine. And it starts with a function. Basically, you have a function, a closed box that does something. And then you have input and you have output, result. And that's the only building model for Church's computation, which was called Lambda calculus. So the simplest possible machine, or function in Lambda calculus was a function called identity function. It's basically a function that accepts a parameter and spits out result, which is the same as parameter. And Church invented this kind of crazy Church notation, which basically continues, is built off lambda and dot. And that's everything. And you have an input, which is the first x, the one on the left side, and then you have, an output, which is the right x. So this is relatively complicated for those who didn't study mathematics. Who studied mathematics here? Nobody. Me included, I didn't. So, but translated to PHP, it's super simple, and there's nothing more than this. Let's take another more complicated example. This function takes two parameters, x and y. So that's lambda x and lambda y. And it's going to spit out result, which is x squared plus y squared. Also, no big deal. And this is kind of PHP version of this function. So functions can be applied to expressions. This wording is ridiculous, but it's actually something pretty simple. You know, you have well, a function, which is basically take x, return x, and then you have our expression, which is some y that is going to put into the function, and then that function is going to return y. And you can chain functions. So in this particular case, you can calculate first, and Lambda functions are always being read from the right to left. So in this particular case, you're going to solve first the problem of summing squares, and then just passing that into identity function, and then identity function returns that. So this is, again, relatively complicated when you read Lambda expressions, but in PHP it actually looks pretty simple. So that's basically foundation of Lambda calculus. However, there is a problem. Lambda calculus does not recognize anything else but functions. So even a Boolean number is a function. So Church defines true as a function that's going to take two parameters and return the first one. That's it. That's a definition of true. Definition of false is Church is going to create, take two parameters and then return the second one. That's a definition of false. Are you bearing with me? Yeah. Yep. And also logical operations are being defined as functions. So he defines and, or, not, and all the other logical operations. And for example, and is a function that's going to take two parameters. Let's call them P and Q, and then apply P to Q, and then apply the result to P. Is this a little bit complicated right now? You don't trust me. Let's try to prove it. So as we defined, and means take P, take Q, and then return, apply P, Q, P to it. And then we are going to take two parameters, for example, true and false. And then we start substituting things. So if P is true and Q is false, simple substitution means that we are going to end up with the result true, false, true. That's P, Q, P, right? And then we are going to substitute the first true with the definition. And I'm talking about, Lambda calculus definition of true, which is take A and B and return the first parameter, which is A. And yes, after the substitution, we are going to end up with take A, B, and return A, where A is false and B is true, and which is false. So this is ridiculous, but it works. Let's go to even more ridiculous example. Everything is a function. Even a natural number is a function. So we do not know the concept of 1, 2, 10. What we know is that number 0 is actually a function that takes another function and the parameter, and then applies the function to the parameter precisely 0 times. So in PHP, this would be a definition of 0. Take a function, take an x, and return that x without applying function to it. Number 1 would be defined similarly. So take a function, take an x, and apply function precisely once on that x. And it goes on. So this is ridiculous. Does it make any sense? To whom it does make sense? To Church only.
It's also piano arithmetics.
Precisely. So if you want to, calculate something super simple as 1 plus 2, what you're going to do is you're going to apply function that defines number 2 to a function that defines number 1. And just do the basic substitution here. It's color-coded, and you're going to count basically Fs and you result in 3 Fs. So addition works. I tried all the other operations, arithmetic operations, they all work, and I'm not going to bother with that. Try to imagine, this all is happening in 1936. So we do not have general purpose computer. We have specialized computers, that's not a problem. But we don't have a general computer. So we are trying to decide the best possible architecture for computers. And we were all doing lambda calculuses. If there wasn't for this guy, who knows about John von Neumann? Not many people. Okay, so he gave us von Neumann's architecture, or von Neumann's model. But he's actually quite an interesting character. So John von Neumann, or Neumann János from Hungary, was like really talented, really extrovert, filthy rich guy who emigrated from Hungary to Germany and then from Germany to the United States. Wherever he emigrated, he changed his name. So in Germany, he was Johann von Neumann. In the United States, he was like John von Neumann, and he really liked to be called Johnny. He was a party maniac, and I thought he actually died from all of partying, which was not really correct. He was also involved with Project Manhattan, so he was exposed to too much radiation there, and he didn't believe in it, I guess. So what he gave us was von Neumann's model. Now, this is still, like today, we are using this model, and all the CPUs are actually built kind of with this in mind. You have a limited number of components. You have this ALU, arithmetic logic unit, which actually does mathematical operations. You have control unit, which decides what is going to happen with data. You have an input device, which is going to input the data into processor. You have output device, which is screen, whatever. And it has a memory. Now, memory is a key part of the thing because in von Neumann's model, memory actually combines both data and the program. And it is a big key value store where you have key, which is an address, and you have value, which may be a variable or an operation. And then you have this long line of commands that is being executed from the first one to the last one. Basically a rule book, and that's the machine language we have today. So really, what happened is Turing's model won. And we got higher level languages. Who knows which language is this? Basic. Come on. Who grew up programming Basic? Yeah, it's awesome. So, and Basic is relatively stupid language, even though it's high level language. So, but still, it is being compiled to the same really stupid machine language. And, this is PHP, which is much more modern language, and it also is being compiled to the same, machine language. And then we have all those crazy abstractions, like classes and object-oriented programming, and it's still being compiled to the same boring linear machine language. So we thought that's it. That was like the epic win of Turing's model. However, the academia continued building their own lambda calculus-based languages and style of programming, which is functional programming. And we ended up with a lot of, either purely functional languages or really focused on function languages. So, and for some use cases, these languages are actually really pragmatic choice. So let's try to make a step in direction of moving, functional way of programming into PHP and see what's really that we have to apply and what are we going to get for it. So let's start with immutability. So immutability basically means that once you set a variable, you cannot do anything with it. You cannot, you can only destroy it. You cannot change it. The concept is existing in JavaScript since ECMAScript, 6, I guess, or something. In PHP, it does not exist. So if you want to make an immutable variable, you're going to define a class. That class is going to have a constructor, but it's not going to have, setter. So basically, you end up with constructing a class which contains, some data, and then you get it, and you cannot really change it. You can just destroy it. So the question whether this is pragmatic or not. Do you want to enforce immutability in this way? I don't know. I mean, to me, it looks like too much. So question for you, what do you think? Is enforcing mutability in PHP worth the effort? Who's for yes? Yeah. So another concept of very important concept of functional programming is static typing, which we got since PHP 7. Well, we got it earlier, but with PHP 7 we have it in with those. What's the name of it? Simple variables or no? Integers, strings, etc. So basically, you're going to define static types of your function inputs and function outputs, which basically means that on compile time, which is in PHP the same as runtime, you can control crazy outputs or things that are unplanned. And another super important concept of functional programming is for given variables or arguments for a function, you can always be 100% sure that function is going to always return the same, strictly defined answer. So if you feed to a sinus function pi, you know that it's going to return 0, always. Saying that, you can actually replace this function with a table, key value table. And that's super important concept. This gives you predictability. Another important concept of functional programming is elimination of side effects, which basically means that during the execution, function is not going to do anything else but return their values. It's not going to save into a database. It's not going to, change any other state outside of it. It's just going to do something, return the answer without changing anything else. So basically, user-safe function in PHP would not be possible if it was developed with functional programming. Now, I mentioned monads in the beginning of the session. So basically, monads are kind of designed way to avoid changing states or keeping states containerized inside themselves and then just executing whatever needs to be executed in the end of the, program execution. A pure function, functional style of programming requires a function not to have any external dependencies, which actually means that function can accept an argument, return a response, and it should not talk to any other external thing during its execution. So loading data from the database is not pure and should be done in the beginning of the execution and then in a monad or something. So it's important concept but it's difficult to be achieved. And really interesting part of functional programming are higher order functions, which basically means functions that can accept other functions as parameters and return a function if they want to. So array filter would be one higher order function which takes a user and a callback and then executes callback, a list of users and executes callback on each of the users. This is one example, and this is another example. And functions are something called, in functional programming, first-class function, meaning that you can assign a function to a variable and then work with it as any other variable. So you can basically pass it around, and it kind of fits together with the previous concept. So the real question is, why would I do this? Why would I, try to change my way of programming? And these are some of the reasons. functionally written code is extremely simple to test. Functionally written code is extremely simple to be cached. Arguably, functionally written code is less complex and more performant. So really, if you think about function as a pure function which accepts parameters and always returns predictable results for those parameters, and if you can replace a function with a table, that means that you can have a testing framework which is going to be fed with a table of parameters and results, expected results, and then you would just look through the function and see if given parameters return given results. No mocking necessary. So who writes tests and who hates mocks? Okay, I hate them. I hate them because, okay, they're good, but they take too much time. So really, this kind of testing does not require you to mock anything because there's nothing to be mocked. And also, caching, for the same reason. If you can replace a function with a table, that means that you can store that table somewhere in memory and just continue living your life without thinking about caching. You don't have to invalidate caches because the function never changes, results of your execution never change. So yeah, this is a relatively simple way of caching things. And in functional programming, caching is called memoization, and it's a little bit specific. So let's try to write a code that's going to memoize another function. So you have read this really super terribly expensive function that takes parameters and does something with them, and you want to memoize it. So first you're going to write a memoize function that's going to call that function, and then you just wrap the function into memoize function, which is kind of starting point for your memoization, still doesn't do anything. Then you are going to define some sort of static storage, whenever you execute the function, it is going to check the storage first, and if you don't have anything in storage, it's going to use parameters as basically keys and execute function, store the answer, and yeah, that's it. So thing is, this is for PHP a little bit too much work, especially because in other functional languages, you have memoization as part of the language specifications. But if we can live with this, we can actually enjoy functional PHP. And it was arguably, functional programming is going to help you reduce the complexity of your programs, which does not mean less code to write. It means easier to read, easier to maintain. And this is a quote about, abstraction and everything. So basically, you don't want to think about plumbing problems, or you don't want to think about stupid solve-over problems. You want to concentrate on business logic. So that's basically what higher level abstraction means. You don't want to think about pushing and popping. Who knows about these concepts? Okay, so pushing and popping actually is the way how to manage memory. And your PHP programmers, you don't want to do memory management. That's reserved for C programmers, right? So really, we want to abstract away the stack and memory management. So what else can we abstract away in order to make our code a little bit easier to read and maintain? So loops. Loops are not business logic. And sometimes we are defining ridiculously complex loops. And we would be happier if we could abstract away the loop. So in this particular case, we are looping through a collection. We are doing some filtering, and we are doing some addition. But that's not really readable. You have to actually read the entire code in order to understand what's happening inside. But this is the way we kind of got used to work. So what if we could do something like this? So we would run filter, and then map, and then reduce on a collection. Who knows what filter, map, and reduce are as concepts? I shouldn't be bothering too much about it. So filtering is basically, well, it's that, like filtering. Map is iteration through every result of the above. Filtering and reduction is then reduction of that result, mapped result to a single value. So yeah, that can be abstracted away, and in order to do that, you have to, because this is not really supported by PHP, you have to use or write your own library. So I wrote this library just for the purpose of this presentation, but it's not really, you know, like you can write it by yourself. It's super easy. So there is a problem though. So once you abstract away the loop, you're going to allow PHP to loop through, you know, first the entire collection to do filtering, then loop through filter results in order to, map and multiply things, and then again loop through the results of mapping in order to reduce to a single value. This is too much looping, and well, functional languages kind of in their compilers have the concept of that and kind of are squashing this into a single loop, or something that's not really happening with PHP. PHP will do this for you. So what can else be abstracted away? One of the things is, you know, design patterns. Design patterns are not really a business logic. They're there to, you know, make our code a little bit more reusable, a little bit, well, more beautiful or elegant, but they are not business logic. So let's take an example of decorated pattern. Who knows decorated pattern? Decorator, come on. Only 2 people. Jesus. Okay, so decorator is a pattern that allows you to change kind of recipe for classes on a runtime. So, for example, you want, you know, to have a pizza. And that pizza, you know, at the beginning of the execution, you're not really sure if it's going to have, you know, mushrooms, mozzarella, basil, or whatever inside. So you're going to create this UML diagram here, which is, well, defining mushrooms, mozzarella, and basil as classes. And they all inherit from abstract class topping, because they are all toppings. And topping is something that you can sell. So topping implements a sellable interface. Now pizza is not a topping, but it is also a sellable thing. So what you're going to do is you're going to create a pizza, and then you're going to say, okay, mushroom pizza is a new mushrooms pizza. So mushrooms is going to accept this pizza object and add mushrooms on top of it. And then you're going to repeat by creating mushroom mozzarella pizza, which is actually a new mozzarella, taking mushroom pizza and then just decorating it with mozzarella things. And it goes on. Or you can, if this code is not expressive enough, you can do something like this, you know, create this bad pizza, which is new basil, new mozzarella, new mushrooms, new pizza. My question for you, what is bad pizza here? Instance of which class? Come on. Basil. So my bad pizza is actually basil, not a pizza. It is sellable, but... So this is the way we decorate things. If we abstract away decorator, we can use something called composition. Now composition basically means take recipe for mushrooms, mozzarella, and basil and combine them together into a bad pizza. Okay? So, and it works like this. So if you define mushrooms as a function that takes price and returns, you know, increases that price by 1, or mozzarella increases price by 2, or basil increases price by 0.5, monies, in together you can, you know, like define bad pizza price or calculate bad pizza price by, you know, taking base price, which is, for example, €4 or whatever, and, you know, just add it into bad pizza. So And if you want to change this bad pizza, because bad pizza is actually going to be a function, you understand that? If you want to change bad pizza, you can do it by composing new ingredients on top of it. So take bad pizza and then just add mozzarella and another mozzarella, why not, to it to make it better. So composition is a beautiful syntactic sugar on top of your code. There is a problem though, it doesn't work in PHP. So in order to make it work, you have to, create first, to use this boilerplate. And this boilerplate actually introduces this identity function we talked about in the beginning. Because if you want to compose functions, you have to have some starting value, and starting value has to be function because you're working with functions, so you're converting a value into a function using identity. Does this make sense? Not really, not really. Good thing is we have libraries, and we have Composer, and we can require functional PHP, primitives for PHP. And those primitives actually allows us to have this kind of syntactic sugar without programming it. So functional/compose is going to give us compose function, and we are just going to be able to compose whatever we want. Or if we want to memoize, we can use functional/memoize and just get over with it. Or if we want to do some cool things on traversable objects and arrays, we can do that too. So basically, here you have like this, filter for every value in in an array. Do something, or selecting or invoking things. If you have an array of other functions and you want to invoke every one of them, so it gets better. There is a matter of performance. Functional programming kind of promises better performance. However, in PHP, that is not really the case. As you can see, imperative programming is much faster than functional, like vanilla functional, and which is even faster than using a library. So, is this myth about performance busted? Well, not really, because if you are developing an application that does not have any side effects, so it does some really expensive computation, it results without touching any other system, you can actually parallelize. Take this example. So this is something I'm working on at Platform SH. So basically, we have one billing night, which loops through all the orders we have in the system, and then we need to charge people, complete orders, issue invoices, send emails, things like that. And just imagine, if you had 1,000 invoices we need to process during the night, and if we were doing optimistically 1 minute per job, that's 16 hours, almost 17 hours of work just to invoice all the people, and that's one long cron job, and we do not really want that. And what is the bottleneck here? Well, issuing the invoice, because issuing the invoice for us actually means take some data and create PDF, and then send that PDF. And creating PDF does not really produce any other side effects but PDF files. So if we could just create a queue which would create those PDFs, and then parallelize process of creation of PDFs, and then send emails as callback after the end of PDF creation. Basically, we can speed this up. But even better, we could do something really amazing. We could upload this PDF creating function somewhere in a cloud, and then let it stand there, and then let it be executed only on requests. So give me PDFs for this invoice. This is your PDF, and that's the only thing that's happening. Does anybody know about this technology and what's the name of it?
Serverless.
It's so stupid name. So yes, it's serverless. So basically it means compute service on demand. which actually means, like this function stands somewhere, and you're not really sure if there is a virtual machine, or if there is a container, or if there is a cluster of containers, virtual machines, whatever's. They just stand there and wait for requests. And then once request comes, if your function is going to be bound with a lot of requests, the infrastructure and the underlying infrastructure is going to spin out a lot of these containers, and they're all going to do your job while the requests are coming. And you're paying only during the execution of these functions. So in our case, because we are billing in every first of the month, that would mean, like 30 days a month, you are not really, paying for this service. And AWS has it. It's called Lambda, and it supports, well, now I believe it even supports PHP, but Java, Python, Node.js, C#. Google Cloud Functions also has it. Azure too, IBM too, who wants to use that? So, and really, it can execute functions either on events or HTTP requests, which gives you great power. So you can use that. Do not be zealous about using now functional programming. That's kind of a big pitfall, because PHP is versatile. It is paradigm agnostic. It's general purpose programming language, but it's not a functional language. So you don't really have to, be super zealous about it. Now, monads. Monads are like the most important and most amazing theoretical concept in functional programming, which allows you to actually, deal with side effects only in the beginning of your execution of your program and in the end. And without them, functional languages such as Haskell would be absolutely useless, because, you wouldn't be able to read from database, saved into database. But do you really need them in PHP? Probably not. However, if you decide to use functional language, with functional style of programming, together with object-oriented style, something that we already do, then your programs are going to start looking more and more beautiful and be more and more, well, testable. So give it a try. It's good. And if you are a full-stack developer, you already have a language that you use that's 100% functional. It's beautiful. It works. All the functional things are right there available to you. It's called JavaScript. So functional programming in JavaScript is really awesome, really productive, and most of the browsers are actually supporting this kind of, they're combining filters, map, reduces in a pipeline and ensuring that executing super fast and is in as least loops as humanly possible. Thank you. Do you have any questions?
How far you can go using functional programming with PHP?
When you start using functional paradigms, you kind of start injecting it everywhere. So then you start doing array maps wherever you want to look for something, when it's possible, of course, or array filters. But it's not overwhelmingly a lot of use cases when you can be fully functional. But it's a great thing. For example, I'm preparing for this Haskell project, so it's super interesting to start learning functional paradigms before you move to something that you don't have any other way but functional. Yeah.
So what I kind of understood from your talk, thank you very much, it was delightful, is we can continue programming PHP as we always have, and maybe just use some functional programming primitives.
And then
now and then to clean up the code a bit, and I also have a feeling the functional programming principles tell you what is a code smell.
Precisely.
But what I don't get is, okay, I want to go crazy and do modern PHP programming using functional programming, like from the core. How do I do away with all this pure function idea that I don't touch my database inside the function, or the dependency injection and the services use things that you see in Drupal 8 a lot? How do you refactor that kind of code or change your habits? When do you store something in the database if you're writing functional?
Well, think about this. So if you're writing a class, and that class has multiple methods, how many of them should really change the state? And can you just ensure that you have a state changing methods as infrequent as possible? So to give you a better example, like Drupal hooks and the entire hook system, which gives us a great power, but it's so difficult to debug once you start using it massively. Why? Because you're loading a user object, and you know what to expect from the database, for example. And then you end up with a user object that has nothing to do with the database. What happened to it? Well, somebody hooked into it. So, and how many frustrations do you have as a Drupal developer when you start debugging? So these big systems with a lot of hook changes, state changes through the execution. So my idea basically is, let's try to not to change state whenever we possibly can, and let's try to keep the state changing functions or functionality or logic as contained as possible. So for example, if you're writing a class, you can have two state changing methods. Everything else would be pure, and then you can test those methods, and you can ensure that they're doing what they were built to do. Was that a good answer?
It will do, but it's very abstract. I need to just see some code to figure out, okay, what's a different way to do that. I'm just thinking, for example, specifically with a function, and you have a method of an object that has some services injected to it during construction time. Inside one of your methods, you call one or X services, and you start changing state of whatever.
That's an external dependency. So basically, functional programming means try to avoid that,
Yeah.
and do not be too zealous by using monads for that, which you could. Monads are built for that and really for that. Now, let's try not to do it. Any more questions? Rotten Tomatoes. I like Rotten Tomatoes.
So, and maybe a vintage question, if I may, like this memoization idea. Is it a good example, or the Drupal static function from Drupal 7? Is that memoization?
That is a memoization, but and it will work only if you have a function that has predictable outputs. But yeah, that's perfect example. Okay, then that's it. Thank you for having me here. I'm going to have another presentation in an hour in the same room. So if you want to listen about CI and setting up GitLab and running it together with Platform SH, come. It's going to be a much more nerdier presentation than here. This.